Let's take a look at how to read and understand a graph of a trigonometric function to identify things like the period, the amplitude, and the midline of a trig function. So in this particular example, what we have is the graph that shows your height above the ground, measured in meters, after t minutes that has passed by as you're riding on a Ferris wheel. Now we're told that you board the Ferris wheel prior to time t equals 0, and that makes sense because if we take a look at that point when t equals 0, so let me label t equals 0, and I'll call that point A. You can see that at point A, you're already 80 feet above the ground. So how are you already 80 feet above the ground on the Ferris wheel at t equals 0? So that means you must have hopped on, right, when the Ferris wheel was, your height above the ground was at 0, right? So that would be some time before t equals 0. So this graph right here shows where you are on the Ferris wheel at t equals 0 and how much time has passed by as you're on the Ferris wheel. So I always tell students that whenever you have a graph of a trigonometric function, somewhere on your paper, just make a sketch of a circle and think about that function in the same way you would think about this Ferris wheel problem. So here's my circle that represents the Ferris wheel. And if I mark some points on this circle, so let's mark some points on the graph and correspond it with points on the circle. So at point A, we see that we are halfway up the Ferris wheel. Now, how do I know I'm halfway up the Ferris wheel? Because if I take a look at another point, let's call this point B, we can see that from point A to point B, as time goes on, so as time goes on from t equals 0 to some t at point B, and we'll figure out what that t value is in just a minute, we can see that our height is decreasing. So we're going down the Ferris wheel, so our height, right, from 80 feet, it starts to decrease, and then at point B, our height is 0. It's not feet, it's measured in meters, so I apologize. I keep saying feet, but I mean meters. Okay, so you're at 0 meters at point B. So on the circle here, if I'm on the Ferris wheel, that means that at point A, right, I must be located there on the Ferris wheel. And then after some time has passed by, I'm now at the bottom of the Ferris wheel where my height is 0. So I'm at point B. But as time continues on, okay, I move from point B to another point, which I'll call point C. So hopefully you can see that some more time has passed by between point B and point C. Okay, so that's another T. So I'll call this T sub 1, this is T sub 2, and that's T sub 3. So some time has also passed by. And now I am back to the midpoint. I'm halfway up the Ferris wheel again, okay? Right? And I know that's where I am on the Ferris wheel on the circle that I've just marked here because, again, my height is increasing. And then as more time passes by, okay, so as more time passes by, I continue to increase in height, and then I reach point D. And notice point D is the maximum point on the graph. So that must also correspond with the maximum point on the Ferris wheel, which means that now I'm at the very top of the Ferris wheel. So at the very top of the Ferris wheel, my height above ground is 160 meters. So right away, that gives you the information you need to calculate the diameter of the Ferris wheel. It tells you, right, the difference between the minimum value and the maximum value of the graph, right? That gives us our diameter. And once you know your diameter, if you split it in half, so if you split it in half, that gives us that 80 meters above the ground. Then from here, hopefully you can see that that is your midline. So there is your midline at 80 meters. Okay, but if you take a look at question A wants to know how long does it take for you to complete one full rotation on the Ferris wheel. So right now, if we take a look at this Ferris wheel, I have not completed one full rotation yet. I've only completed 3/4 of a rotation on the Ferris wheel. So to complete one full rotation on the Ferris wheel from point D, I have to travel back to point A. Okay, so on the graph here, right, notice that I'm falling back down towards the ground, so my height's going to start decreasing, and then I land at another point, which I'll call point E, but hopefully you can see point E puts me right back at point A, and now I have completed one full rotation. So if I want to know how much time has passed by, I can take a look at points A through point E and divide time, right, into these nice even quarters. You can think of them as quarters, okay? So as I move from point A to point B and point B to point C and point C to point D, we can see on the graph, let me try and use a different color here. So maybe I'll choose hot pink here. So as I move, or let me choose green so that there's more contrast. As I move from point A to point B to point C to point D, hopefully you can see that 15 minutes has passed by. And so if I divide that into thirds, I can see that from A to B, 5 minutes has passed by. From B to C, another 5 minutes has passed by. And from C to D, another 5 minutes has passed by. All right, so 15 divided by 3, that's where I got the 5 minutes from. Okay, and so to get back to point A from D to E, that must be another 5 minutes. Okay, so that tells me that to complete one full rotation, so to complete one full rotation to go from point A to point E, right? If I take 5 and add it to 15, that tells me that it took me 20 minutes, okay? So 20 minutes to complete one full rotation. So these are the connections that you want to make when you're trying to figure out the period of your function, how long it takes to make one complete cycle when you have the graph of this sine function or this cosine function. Just associate it with a circle. And that's why you'll see later on that trig functions, right, are closely related to the unit circle because they behave in the same way. So I really hope that this video helps explain some of those important concepts of a trig function.